Welcome. In this video, I'm going to show you how we're going to write tests that make us better engineers by writing fewer defects, being more productive, all while writing tests that aren't going to be annoying to manage. Let's get started. I'm going to be using a function that I ran into recently in a real world usage. This function is called $2 and I'm going to go through some use cases here to tell you the general idea of what this function is supposed to do. Now we're going to look at writing unit tests first because I want to show you how by writing the unit test first, it can make development go much more quickly. All right, here are some basic unit tests for this function. This function receives the number that we're converting from and the value that we expect after the conversion. I'm using the test format from behavior-driven design, given when then, which is given some state that already exists, when some action is taken, then we expect some results. So given that we have from, I just commented this out because this isn't really a statement, but given that we have this from value, when we convert dollars to cents, we expect the cents to be the expected value. And up here is the test cases. So when we pass 1.23, $1.23, we expect to receive back 123 cents. When we pass the value 1 with no decimal point, just a whole dollar, we expect to get 100 cents back. Now we're going to talk about something a little bit more complicated. Let's look at a different test case. Okay, we have a slightly more complicated test here dealing with precision beyond cents. Now, if you're given $1.23.5, perhaps most correct answer would be to return 123.5 cents. But it turns out that our needs for this function is that it returns an integer. We can't allow fractional cents. So here we're saying that we're willing to accept either 123 or 124. What we're doing here is specifying what we need the code to do. What we're not doing here is specifying what the code does. Now, this is a pretty significant difference. We didn't already write the code, figured out, oh, what does it do when it gets a half penny, and then write the test to say, oh yeah, it does that. Rather, we're starting with the test so that we can start by thinking about what are the requirements? What do we need the code to do? And it turns out that the requirements are that we have to return an integer and we don't care whether we round up or round down. So now, by saying that we accept either value, the implementation is free to change, and this test won't fail if it changes from rounding up to rounding down, because when the implementation changes, it's still correct. We want to avoid false negatives. We want to avoid tests that will fail just because the code that we're testing has changed. We want a test to fail only when there's a defect. This makes us more productive. This makes us have a different relationship to the tests. Instead of tests being this annoying thing that fails all of the time, now, tests are something that you can actually rely on. Oh, when this test fails, I know there's a problem. It's not just an annoyance. We actually can't accept partial pennies, except for we still want to do sort of like a best effort and convert it to something so that it's close, so that we have a useful value while we figure out how did we get the partial penny in the first place, figure out what that means, talk to the system that gave us that value, and see if we can get this corrected. What we don't want to do is just return this integer value, let it end up in the UI, and wait for someone to notice that the value is wrong. We want to detect that something has gone wrong, and we want to alert. We want to warn someone, hey, something has happened. Look into this. That allows us to more quickly find defects and more quickly fix them, and fewer defects are going to get to the customer. So let's see how we're going to do this. Okay, here we are. We've got our ability to warn now. Turns out that the system that this function runs in has a dedicated function to warn about this exact kind of thing. We're going to pass the warn function to our conversion function, and we're going to assert that the warning has been called. Now, there's many ways to write this assertion. This is perhaps the loosest way. We're not asserting specifically what the warning message is. We're not asserting that warn was called a very specific number of times. We're just saying that it's been called. Now, there's pros and cons to this choice. The pro is that we're not going to get a false negative. This test isn't going to fail just because some code changed. If someone changed the log message, for example, and you may notice that we're passing the warn function in rather than just calling, let's say, console.warn, the global warn function. And that's because we're following solid engineering principles. And the I in solid means inversion of control, which is also called dependency injection. And inversion of control and dependency injection are just really fancy words for pass the thing in as an argument. So instead of dollars to cents calling the global console warn function, instead we pass that function in. And that allows us to write this test very easily without having to do what's called spying or modifying the global state, which then makes it so that we can't run and test in parallel or as quickly or with as few resources that we could with this. So this is the best practice for so many reasons. I won't even get into it right now. You can search on the internet for dependency injection or inversion of control and learn all the reasons why this is the better way of doing things. Pass your dependencies in as arguments. That's what we call dependency injection. Now, here we're asserting that the warning function has been called. Well, let's go back to our previous tests, and perhaps here we want to assert that warn was not called. So let's make that change. Okay, here's the change. We're asserting that these are true, legitimate values that we're perfectly happy with that produces no warnings. So not only does it work and not throw an error, but that these are values that we're happy with. It turns out we actually support string values as well. And I made a typo up here on top. I call these string values. These are actually number values. And we're going to make a new section for string values. All right, here we have our first test of string values. This is a little bit more complicated in that we are testing a cross product of different options. Let me just show you that this is the array of test cases, and the test case basically combines every prefix with the string 1.23 and adds every suffix. So here again, we have our mock function, and we're asserting that all these values, all these combinations, we should be able to handle without any warning whatsoever. Okay, here are some negative test cases for strings. If we have a string that's just a $sign, or just the currency designation of USD, or just some text with some numbers in it, these are all cases where we expect the conversion to return null. And we want to warn that we got some string that we don't know how to convert into a number. And for now, we're just going to say that there's no value. Now, this is better than saying that the value is 0 or that the value is -1, because someone might interpret that as being 0 cents or -1 cents, because we support both 0 and negative numbers, as you saw on a previous case. So we can't use those to mean something special. We use null to represent no value. Okay, now we're going to talk about values that are not numbers and not strings. These values that we're getting that we have to convert from dollars to cents, these values are being deserialized from data that was sent over a network. And while it might be possible that something upstream from this function validates the schema of that data ahead of time, it turns out in this case that does not happen. So we need to do this validation. I've got some cases here where we pass an array, an object, and a Boolean. Now, this is actually just an empty array. The fact that it's an array and an array is a weird thing about this testing framework. Ignore it. Just pretend that this is an array. So here in this case, these are invalid values. And again, with those strings that we don't support, we want to return null. And we warn to let folks know that something is awry, something needs to be looked at. And the reason why we want to do that is because it turns out that null is a valid value. So just returning null on its own is not sufficient for the caller to understand that something has gone wrong. So here in this test, we're saying that undefined and null are valid values, that when undefined and null are passed, that it returns null, and that warn is not called because they're valid. We don't need to warn. So this is how we make a distinction between a null that is valid and a null that is the result of something gone wrong. Okay, so now we've got a bunch of test cases. We've got tests for number values, string values, and other values. Now let's go ahead and run these tests against the code that we've already got. Now we're doing this before we look at the code because we should be focused on test first. We need to know what the code needs to do. So it turns out we've got 31 test cases and 7 of them have failed. So now let's go look at this function that we've been talking about this whole time. Okay, here it is. Normally, I would say let's make all the tests pass before we do any cleanup, but having already done a couple of passes on this code, I can tell you in this case, it's going to be a lot easier for us to work on this if we do the cleanup at least partially before we start making these tests pass. The first thing cleanup-wise is I'm going to say, let's look at our warnings. So this is a big tip. We've got this exclamation point up here. This is telling us there's a warning. It turns out that this warning is quite useful, and I would recommend always making sure that there's no warnings. When there's no warnings, you get a green check mark up here, and you want to always get the green check mark. If you are getting a warning that you know you can ignore, then mark it as an exception to the rule so that IntelliJ or whatever your IDE is stops warning you about it so that you can trust that the warnings are meaningful and you need to look at them. Okay, so the warning here is invalid type of check. Value cannot have the type of Boolean. And what this is saying is that by the time execution gets here, it turns out that this is always false. In IntelliJ, this can do a little refactoring for us automatically. So I'm just going to do Option and Enter. Now, Option Enter is the key command on Mac. I don't know what the key command is on other operating systems, but this is one of the things I really love about IntelliJ. There's a ton of these automatic refactorings built in. This is giving us a little preview on the right of what it's going to do, that this highlighted bit right above our pop-up menu is going to be converted into the highlighted bit in the preview. So let's go ahead and do that simplification. There we go. So now we have a new warning because now that we've simplified it to false, it turns out or false is meaningless. So we can Option Enter again, and now it'll simplify it again. Now we've just made our code faster because now we're going to do one less type check. Isn't that great? By paying attention to our warnings, we made our code faster, and we all want faster code. There's also less code, and it does exactly the same thing that it did before. Now that we've taken care of the warning, let's actually walk through this code together and see what it does. This is saying that if the type of the value that we've been given, if it's not a string and it's not a number, then we're going to return null. Now, if it is a string and it's an empty string, then we're also going to return null. So by the time we get here, we know it's either a string or a number. Now here, we are casting value as string or number. And that seems a little redundant because we already know it's string or number. In fact, we can hover over this and it'll tell you that we already know that value is string or number. So we can delete this cast. It is completely useless. Now we can simplify this a little bit. So what we can do is just put value in here, and then just declare it here on this line. So now we've deleted a line of code, and I would argue that this isn't any harder to understand. Maybe it's even a little easier to understand. So now we've got in here, we know that value is either a number or a string. Regardless, we're going to convert it to a string. That's what this does. I would argue someone might look at this and not realize that all this is doing is converting this to a string. Let's make this a little more obvious so that the code's easier to read. This does exactly what it did before, but now it's a bit clearer as to what is going on. What this is doing is replacing any character that's not a digit, a decimal point, or a minus sign. It's replacing everything other than those with empty string. We check here if it's an empty string. That's not obvious. I first looked at this and thought, oh, this is checking to see if normalized value is defined. But I know it's defined. I know value is defined, and I know replace is going to return a string no matter what. So why is this not warning me that we already know that this is defined? Just like up here, we already knew it wasn't Boolean. Here, we should know that it's already defined. Well, it's checking truthiness. And it turns out that an empty string is falsy. This is one of those weird things in JavaScript. Everyone likes to complain, oh, JavaScript is so weird. There's all these idiosyncrasies. It's such a crazy language. And true, this is one of those places where this is actually kind of confusing. I think it's pretty rare to run into these weird JavaScript edge cases because for the most part, we should write our code such that we never really run into those situations. All right, so this is saying that if it's not an empty string and it includes a period. Now, this is redundant because if it does include a period, that we already know it's not an empty string. So why are we checking to see if it's non-empty and includes a period? So let's go ahead and remove this. This is completely redundant. Our code is faster. Okay, so if there's a decimal point in our number, then what are we doing? We're taking a substring, finding the index of that period, and plus 3. I'll tell you what this is doing is truncating the value to only 2 decimal points. Now, what's next? I'm just going to reformat this because I always have a difficult time following ternaries. I put the predicate on one line, I put the true path on the next, and the false path on the next line. I always format my ternaries like this. I find it much easier to read. So this is saying if normalized value. Again, this is checking to see if normalized value is an empty string. This is not obvious to me that this is what's going on. Let me just type this in a different way so it's a bit more clear. This is doing exactly what it did before. And now that I've formatted it like this, we can make another optimization. Because here we say, well, if it includes a decimal point, then we're going to do this substring where we do include the decimal point. We're going to keep the decimal point in there. So when this operation is done, we know that normalized value will not be an empty string. Well, if we took this path and we know that we ended up with a value with a decimal point in it, we don't need to check to see if it's empty. We know it's not empty. So what we can do here is turn this into an else if. And look at that. Now we've made an optimization. So anytime this branch is taken, we no longer have to test this. Faster code. Beautiful. I love it. When we have a non-empty string at this point, we parse it into a number, then we multiply it by 100, and then we round it. We've already truncated to 2 decimal places. We're moving that decimal point by 2. And in this case, math.round doesn't do anything. So when there's a decimal point, we floor. When there's no decimal point, we round. So we have 2 different behaviors depending on whether it's a whole number or if it includes a decimal point. Why don't we just do the same thing every time? Now, remember we were talking about we don't care if we round up or we round down. I want to pull forward this idea that we don't care if we round up or we round down. We don't need to floor it anymore. We don't need to truncate because we're just going to round it anyway. We don't need this operation at all. Let's just take this out. Wow, this code has gotten so much simpler. Now that we're not reassigning normalized value, this no longer has to be a mutable reference. So we can say that this is const. And if you know me, you know I love having everything be immutable. This might be a good place to stop with the cleanup. I can see maybe a couple other things to do. Well, I don't know. Let's go run the test. Now, remember last time we ran the tests, we had 38 tests, 31 passed, and 7 failed. I think that when I rerun these, I'm going to get 7 failed tests again. I think that's true. I'm trying to think about when I run the test, what results will I get? And I would recommend that you do the same. Before you run a test, think to yourself, what do you expect the test to do? If you expect the test to fail, why do you expect it to fail? It's a good practice to build up your mental model and sort of exercise that muscle that you've got to think about code abstractly in your head. Okay, let's run these tests. Again, I think I'm going to get 7 failed tests. And I do. I get 7 failed tests. And I'll tell you right now, it's the same 7 failed tests. I've already looked into this. Now let's get some tests passing. Let's fix this code. Now, a lot of these tests have to do with logging, with warning. All of these tests here are failing because we're not warning. That's what this error message means, is saying that we expected our spy to be called at least once and it wasn't called. And when it's talking about the spy, it's talking about this mock here. We're going to start with the first test, work our way down and get these working. All right, so this says it converts extra precision. I want to add to this test name and say, and it warns, because I want to be very clear that we want to warn when we have extra precision. So let's go to the system under test, and I'm going to say that I accept a warn function.
Type of console warn.
Let's go look at our test again. We need to warn when we have extra precision. Okay. How will we know if we have extra precision? Well, if we don't have extra precision, then the rounding won't change the value. Let's save this value as a variable. And we'll call this, I don't know, let's call it number, I guess. I can't think of a better name. Then we're going to round that number and we'll call this rounded. Great. And then we'll say if rounded does not equal number, then we're going to warn. What are we going to warn? Let's see. Let's warn that we have too much precision. And we'll log the original value. So let's rerun this test. And now I have one less test failing. Great. We made progress. Now we have this problem. If we have just a $sign, let's see, we expected +0 to be null. That's interesting. So we expected null, but we got 0. Huh. How could that have happened? So let's see, if we've got a $sign here, let's see, it is a string. So this whole thing will be false and say, or if the value is empty string, well, it's not empty string. So then we go down here and let's see, value to string. We're replacing everything that isn't a digit or period or minus sign with empty string. So that means we're going to replace the $sign with empty string, and normalized value will now be an empty string because that's the only thing in there. Normalized value dot length equals 0, returning 0. Well, I don't know, that seems maybe okay. Let's go see what that error is again. We expected null, but we got 0. Oh, right. We were going to say that whenever we get an invalid value, we're going to return null. Let's change this to null, and then let's rerun our tests. What do we think is going to happen now? I think they're still going to fail. I think I know why. I think it's because it's not going to warn. Here we go. Yeah, it expected the spy to be called at least once, right? So here we have our invalid value, and we want to get null back, but we also want warn to be called. Okay, so let's go fix that. So here we have an invalid value, so we'll say
Warn invalid value.
By the way, this little hint here where it says data, it might be that this is not helpful to you and you just find that annoying, but you find some of them useful. But here it's a logging thing. We know how logging works. We do it all the time, so we don't need this. So in IntelliJ on Mac OS, I can option enter here and I can say do not show hints for this method. Let's rerun the test. I think this test is going to pass now. All right, so we ran all the tests. We have 4 failing tests. So I said that we're going to work our way down, but I actually want to skip over this one. This is a little bit of an interesting one that takes a little bit more conversation. I think we're on a roll with these quick fixes. Let's keep this going. So we're going to skip this one and come down here and talk about these. Here we've got these invalid values of an empty array, an empty object, or a Boolean. And we're saying that we're not warning here. So let's go fix that. By the way, before we fix it, just notice that these two are passing. All right, so let's see. When it's not a string and it's not a number, we return null. Okay, well, this looks like the right place to put the warn. So let's do that. Let's do warn invalid value. So that was easy. That's a quick fix. Let's go ahead and just run all of these now. Now I should, oh, what's going on here? These were passing before, but now they're failing. Let's see, now it's saying that the spy, the warn function, that we expected it to not be called at all, but actually it's been called one time. So these are passing now. So these are getting the warning, but now these are getting a warning when they shouldn't get a warning. Let's go look at that. Yeah, it turns out undefined and null, we want to treat those differently. We're going to do what's called red-green refactor. So red means that the test is failing. This probably doesn't look red to you because I'm actually colorblind and I have the colorblind assist mode on. But red-green refactor means you first get a failing test and then you get it passing and then you clean up your code. And I sort of violated that a little earlier when we did the cleanup. I'm going to try to be good about it now. So I'm going to make the test pass first and then I'm going to refactor. So we'll just say if all right, I think this will do it. So now when we have null or undefined, now we'll log the invalid value and then return null. And then here, we'll just return null. So I think I've got it. Let's go ahead and run our tests. Oh, now we got more tests failing. What happened? Oh, it turns out that I got the logic backwards, that actually this warn goes down here. See how fast that was because I had unit tests? I was able to make this change and run the test and see that it was failing. This was so fast. These tests ran in 9 milliseconds. This is so much faster than just even restarting a server or even the automatic refresh and then having to go to Postman and click submit. This is faster. You can be a more effective engineer. So let's rerun these tests. And now we're down to just this one failing test that I said I wanted to get back to later. I am going to ignore that for right now. So now everything that we're going to pay attention to right now is green. So we went from red to green, and now it is time to refactor. Let's imagine that a number is being passed in as the value. What are all the operations that happen? First, we check to see if it's null. That's one operation. Then we check to see if it's undefined. That's a second operation. Then we check to see if the value is of type string, and it's not. So that's 3 operations. Then we get to see, is this a number? And it is. Then we serialize the number to a string, and then we do a regex, and then we check to see if the resulting value is empty, and then we parse it. We parse it back into a number. We multiply it by 100. Then we round it. We check to see if the rounding changed anything. And then if it didn't, we go ahead and return it. So not counting the return, that is 11 operations for number. Performance is usually not that important, but I'll tell you that this code runs very, very often in the system that it runs inside of. The system it runs inside of deals with money. There's a lot of money values, and the process that this runs inside of, everybody wants it to be faster. And it turns out that right now it is CPU bound. That's why I'm paying attention to this. Based on my experience, I can tell you serializing a number and then parsing it later, that those are fairly heavy operations. Regex, regular expressions, are also heavy. Maybe we can just leave it as a number. Well, we're going to do a little shortcut. We're not going to do all this. Instead, we're just going to do this bit here. So how many operations is this? We have a type check, that's 1. Multiplication is 2. Round is 3. And then this check is 4. And I wasn't counting return before. So we went from 11 operations to 4. We've got some duplication here, right? I just copied and pasted this from up here. So let's get rid of that duplication. Let's turn this into a function. So now we want to also replace the duplication we had below. I guess let's call this parsed. That's probably better. And then up here, say I called this number. Let's call this cents. I think cents is a better value. And I suppose, I guess this would not just be generic value, but this would be, let's say, dollars, right? Because we're converting dollars to cents by multiplying it by 100. And then now we're not just handling any number, we're handling dollars here. And look at that. I think our code is a little more readable now. Well, this is interesting because we already know that it is not of type number, because if it was of type number, we would have taken this branch. So we already know that this is false. We know that this predicate is true, and having and true is pointless. So we're going to remove that. And then now we don't need these additional parentheses because we don't have that compound predicate anymore. Now we say if value is not a string, or if it is a string but empty, then we log invalid value. Oh, wait a second. Here we're saying that an empty string is an invalid value. If that's true, we could just take off this predicate because we can go ahead and run the regex on it, and it's going to remove all these other characters. That's fine. So an empty string with all the stuff removed is just empty string, and then we'll end up down here and we'll say it's invalid. So this seems redundant to check for empty string here. With our system, that we want empty string to be considered valid. It turns out that when we do get an empty string, we don't want to consider that invalid. So we have a defect here. I could just go ahead and fix this, but when you fix a defect, the first thing you should do is write a failing test. Remember, the saying is red, green, refactor. First, you get a red failing test, then you make it passing, then you beautify your code. Write a test first. Whenever you have a defect, you should be writing a test. When you have a defect, what that means is that you were missing a test the whole time. So let's fix that. Let's fix the missing test. Let's make that test. So let's see, I guess we need one more test here. Brown M&M's Van Halen. Go search that and read that story. When I see a problem, I assume that there's more problems around. I want to feel confident in the code that my team writes. Fix your typos. Now in IntelliJ, this is really easy. On Mac OS, I do Option Enter, and there it is. Option Enter, and look, typo fixed. How easy was that? Take pride in your work. Fix your typos. Okay, empty string considered null. This does not read like a sentence. So instead of saying it empty string considered null, we can say converts empty string to null. I like that better. So with all of that, okay, here is our new test, converts empty string to null. Now, before I run this test, I'm going to predict what will happen. I will predict that it fails. That's the whole point of writing the test first. We want the failing test. And I think it'll fail on this line. I think this will be fine, but this is what's going to fail. So we've made that prediction. We're exercising that muscle. Let's run the test. And here we are. We're correct. Great. So let's go back to the system under test and fix this test. All right, I think this will fix the test. Let's go ahead and run it, and it passes. Let's go ahead and run all the tests. And we just have the one test that we're ignoring for right now. We'll come back to that. We did the red test, we got the failing test. Now the test is passing, green. Now time to refactor. What can we do here to refactor? Well, I think we can combine this if and this if up here. So I think that keeps everything passing. Oh, look how fast that was to check. Didn't have to go to Postman or anything. What else can we do here? One optimization is by the time we get down here, we know that value is already a string because here if it's not a string, we're going to end up returning here. So we already know this is a string. There's no point in calling toString again. Now I want to do an operation count if we have a very common string. So let's imagine that we have the string 1, 2, 3, 4, 5, right? So it's a string with a decimal point in it and the cents in there. Okay, so we have the type check to see if it's a number, that's 1. Then we check to see if it's null, that's 2. And I'm going to keep track, but stop counting out loud. Okay, so when we've got the string 123.45, that's 11 operations. That kind of string we expect to be a very common value. So let's see if we can make that faster. Now, when we made number faster, we moved it up on the top. Let's do the same thing for string. Let's see if we broke any tests. I don't think we do. I think we just got that one failing test. And yeah, just the one that we're ignoring for now. All right, so let's do that operation count again. Okay, so that's 9 operations. We went from 11 to 9. Now, that's not a big change, but that's roughly 20%-ish. And that's pretty significant when you're dealing with a system that's CPU bound. And these are going to be the most common values that you have are numbers and strings. This is pretty good. Okay, let's talk about this test where this string is getting converted into $30.10. It's because this regular expression is stripping away all these other characters and then it ends up getting parsed with just those numbers in the period. This regular expression lists all the characters that we want to keep and then it says to get rid of everything else. This is good because we have an inclusion list rather than an exclusion list of characters. That's a good thing to do from a security practice. It's always a good idea to think, what am I willing to accept as opposed to what am I going to reject? But we can take this one step further. Instead of getting rid of the things that you want to reject, instead pluck out the things that you want to keep. Okay, so now I've changed this code to, instead of getting rid of everything that we don't want, we are matching only the things that we do want. I searched the internet for a regular expression to do what I needed it to do, and I pasted here a link to where I found this regular expression. And this is a good practice to list where you got something that isn't going to be immediately apparent what's going on. Maybe you're doing some bit masking or regular expression or just anything that people tend not to have a lot of familiarity with. When you find a solution on the internet, put a link to where you found it in the code so that others can learn from it. Maybe on that page, there'll be updates from other people who are making improvements or fixing defects, and someone later could go and review that, find those improvements, and integrate them into the code. This regular expression matches numbers that we could parse, and it could match multiple numbers. This regular expression finds 2 matches, the 30 and the 1, which means that it is an invalid value, and now the test is finally passing. There are definitely strings that we could pass this function that we might want to consider as invalid, but yet this function would end up parsing a number out of it rather than logging a warning and returning null. So this isn't perfect, but it's better than what we had. We are correctly handling more cases than we were before. All right, I've zoomed the code out a little bit so that we can see all of the previous solution and all of the current solution side by side so we can do a comparison. The new solution is certainly more lines of code, but with those greater lines of code, we get a number of things. One, this function is more consistent. The previous function sometimes did floor and sometimes did round in order to deal with extra precision. And now on the right, we always do the same function. The solution on the left sometimes returned null and other times returned 0 when we had an invalid value. The solution on the right now always returns null. That consistency makes it easier for this function to be used and debugged. Also, and our new solution warns when it runs into an invalid value. The previous solution relied on users or testers to find data errors in the UI and then report them to the developers. Now, the developers can be proactive about dealing with these invalid values. Now, when we're given a number, we keep it a number and it runs tremendously faster than it did before. String values are also faster. And if you walk through the code for null and undefined values, it's the same number of operations as we were doing before. And most important of all, we have a suite of automated tests that define what our requirements are for this function. That's it for this video. I'm honored that you spent this time with me. I hope you found it useful. If you have any questions or comments, leave them down below, and I will see you in the next video.